A year ago, famous American physicist and science communicator Michio Kaku shared his thoughts on 6 primordial galaxies discovered by the James Webb Telescope in an interview with NBC News. It takes many billions of years to create a galaxy, like the Milky Way galaxy with 100 billion stars many billions of years old, but the James Webb Telescope has identified 6 galaxies that exist half a billion years after the Big Bang that are up to 10 times bigger than the Milky Way galaxy. That shouldn't happen. There should not be primordial galaxies that are bigger than the Milky Way galaxy that are only half a billion years old. Something is wrong. We may have to revise our theory of the creation of the universe. While some initially questioned his ideas, subsequent findings from the Webb telescope have increasingly supported his perspective, offering compelling evidence that challenges current models of galaxy formation. Early this year, the JWST discovered a galaxy called Galaxies Z13, formed just 290 million years after the Big Bang. Webb also found another galaxy candidate called Galaxies Z11, which formed 500 million years after the Big Bang. But our cosmic model suggests that the early universe within the first billion years after the Big Bang resembled a bustling construction zone. Galaxies and galaxy clusters were forming and evolving under the influence of gravity, laying the foundation for the modern universe we see today. And now, the James Webb Space Telescope has discovered 3 galactic red monsters, which is what they are calling it, in the early universe, defying our current understanding of how the first galaxies formed. Welcome to Digital Discoveries. This is your space. An international team led by the University of Geneva has identified 3 ultramassive galaxies, nearly as massive as the Milky Way, already in place within the first billion years after the Big Bang. The James Webb Space Telescope's FRESCO program enabled this astonishing discovery, utilizing the NIRCam GRISM spectrograph to precisely determine the distances and stellar masses of galaxies. The results of the study, published in Nature, indicate that the formation of stars in the early universe was far more efficient than our models predict. The favored theoretical model suggests that galaxies gradually form within large halos of dark matter. These halos pull in gas, creating gravitationally bound structures, and generally, only around 20% or less of this gas is converted into stars within galaxies. Yet, these recent findings challenge that perspective. The researchers suggest that massive galaxies in the early universe may have been far more efficient at forming stars compared to their later counterparts, growing at rates much faster than previously believed. The Webb telescope's remarkable capabilities have enabled astronomers to investigate galaxies in the far reaches of the early universe and gain new perspectives on massive dust-embedded galaxies. The FRESCO survey analysis shows that most of these galaxies align well with current theoretical models, but the data also revealed 3 extraordinarily massive galaxies with stellar masses rivaling that of the Milky Way today. These galaxies are forming stars at almost twice the efficiency of their smaller counterparts and those seen in later eras. Because of their high dust content, which gives them a striking red hue in JWST images, they've earned the nickname Red Monsters. Our findings are reshaping our understanding of galaxy formation in the early universe, said Dr. Shah, lead author of the new study. The massive properties of these red monsters were hardly determined before JWST, as they are optically invisible due to dust attenuation, said Dr. David Elbaz. Although these observations are consistent with the prevailing cosmological model, they present new challenges for galaxy formation theories, particularly concerning the presence of too many and too massive galaxies so early in the universe's history. To account for these massive early galaxies with highly efficient star formation, existing models may need to incorporate extraordinary mechanisms that allowed for such rapid development. The thing that makes these massive galaxies so surprising is that they exist so early when we don't think they should have had time to form, said Erica Nelson, assistant professor in the Department of Astrophysical and Planetary Sciences. It's like arriving home from work to check on your kitten and finding a cougar laying on your couch. While Nelson previously helped to identify several of the red monsters in a 2023 study, the new research takes an even closer look at several of these candidates, confirming that they are, in fact, as old and as large as they look. Somehow, these galaxies managed to turn nearly all of their gas into stars in just a few hundred million years, the blink of a cosmological eye, said another scientist from the team. Future research using the Webb telescope and the Atacama Large Millimeter Array, ALMA, will shed more light on these ultramassive red galaxies and likely uncover additional examples of these early cosmic giants. Speaking of the ALMA telescope, here is another fascinating discovery from the beginning of the universe, an impossible galaxy. Enter Rebels 25, a galaxy discovered by the Atacama Large Millimeter Array, ALMA, telescope that has turned everything we thought we knew about galaxy formation on its head. Astronomers were stunned to find that this distant galaxy, which formed just 700 million years after the Big Bang, looks surprisingly like our own Milky Way. It's a massive disk-like galaxy with hints of spiral arms and even a central bar. This discovery has astronomers scratching their heads and asking, how could a galaxy so orderly exist when the universe was still in its infancy? Further observations of this galaxy revealed that it's not just any ordinary early galaxy. It's the most distant, strongly rotating disk galaxy ever found. To confirm these findings, astronomers took a closer look with ALMA. The high-resolution data not only confirmed that Rebels 25 has a rotating disk, but also hinted at other advanced features like a central elongated bar and possibly the beginnings of spiral arms. These characteristics are more in line with mature galaxies like our Milky Way, rather than one born so close to the Big Bang. So where does this leave our cosmology? Well, the discovery of Rebels 25 is shaking up our understanding of the early universe. It suggests that galaxies may have formed and evolved much faster than we previously thought, leaving scientists with exciting new mysteries to explore about the birth and growth of galaxies in the cosmos. But the biggest shockers came in October 2023 and January 2024, when the telescope discovered massive galaxies from the beginning of time. Recent analysis of the discovery points to an uncomfortable reality that could significantly alter the landscape of modern astronomy. These galaxies are not just unusual, they defy our very understanding of cosmic evolution. One of the most perplexing findings is that some of these ancient galaxies contain an amount of mass that should have taken billions of years to accumulate. Yet, they appear fully formed and mature within just a few 100 million years after the Big Bang. The problem is that our current cosmological models predict that galaxies of this scale should not exist so soon after the Big Bang. According to standard theories, it takes billions of years for gas to coalesce under gravity, form stars, and assemble into a mature galaxy. However, what JWST is revealing suggests that either the universe's early years were far more efficient at forming galaxies than we ever imagined, or our entire understanding of cosmology is missing a crucial piece. Some researchers suggest that these findings may hint at unknown physics, perhaps something fundamental about the nature of dark matter or early cosmic inflation that we have yet to understand. Others propose that an entirely new framework may be needed to explain how these galaxies formed so quickly. This is where things get even more intriguing. One radical possibility is that these massive early galaxies could be the result of an alternative formation mechanism, one that bypasses traditional slow galaxy assembly processes. Some astrophysicists have speculated that primordial black holes, formed soon after the Big Bang, may have played a role in accelerating star formation by compressing and heating surrounding gas, triggering rapid stellar birth in ways we have not yet accounted for in our models. Another theory suggests that the early universe may have contained dense pockets of dark matter that enhanced gravitational collapse, allowing these galaxies to form much faster than expected. But the most controversial suggestion? Some physicists have even proposed that these massive early galaxies might hint at the existence of a pre-Big Bang universe. According to this idea, what we call the Big Bang may not have been the absolute beginning of everything, but rather a transition from a prior cosmic state. While this remains speculative, the findings from JWST are forcing cosmologists to reconsider long-held assumptions about the universe's origins. And this is just the beginning. With upcoming surveys from JWST, ALMA, and future telescopes like the Nancy Grace Roman Space Telescope, scientists hope to gather even more data on these mysterious galaxies. If more examples of these massive, mature galaxies continue to appear in JWST's deep space observations, it may demand a dramatic shift in our understanding of the early cosmos. One thing is certain: the James Webb Space Telescope is rewriting the history of the universe in ways we never expected. What do you think? Do these findings suggest an error in our models? Or are they revealing something even more profound about the origins of our universe? Let us know your thoughts in the comments below. If you enjoyed this deep dive into cosmic mysteries, don't forget to like, share, and subscribe for more mind-blowing space discoveries. Thanks for watching Digital Discoveries, and we'll see you in the next one.